All right, good morning, everyone. So we're going to talk about sustainable water resources, but also rather than focus on the technical this morning, I'm going to focus more on how we can make it fun and more user-friendly and just integrate into the theme of the zoo. Okay, so I've met most of you before, but my company Watearth focuses on water resources, and most of our projects include a sustainable component. All right, so we've got our watershed here. Somebody mentioned rain barrels. We could do some cisterns on a larger scale, more for a demonstration purpose. This is at the Fort Worth Botanic Gardens, which does have like some kid-friendly elements to it. Of course, for our very large water capture areas, below ground is going to make a lot more sense, like in the Africa exhibit. But there's probably some strategic places to do the above ground cisterns. Just if we can link it to either landscape irrigation or possibly toilet flushing. But again, is more of a demonstration type element. And so instead of just having kind of a boring cistern, something that integrates into the design of the zoo or the exhibit. All right. Okay, so this next slide is from the stormwater BMP study that was done specifically for the zoo. So we've got various BMPs that were evaluated in the BMP study for the zoo. And then they ended up scoring them. So some of the top scoring ones, and I'll specifically talk about these, but some of the top scoring ones were bioretention, like a dry retention pond, wet detention pond. Preventative maintenance scored really high, and I think probably as a zoo you already understand the importance of maintenance, and that's going to be the key also for the long-term functionality of these water sustainability features. Is nothing's without maintenance, so we want to make sure that in the end there's a good maintenance program in place.
Give us a sense though, what does it mean to have a high score?
I believe what it means to have a high score is that they are more recommended. Yeah. So some of the things like the sand filter has a score of 18 compared to a higher score of 25. Actually, there's 3 different types of sand filters, and some scored very low, like at a 10. So sand filters do an okay job of cleaning water. And they've been used pretty historically. They're going to remove things like TSS, total suspended solids. They do a pretty good job. They're kind of on par with like permeable pavement. But the problem is that's all they do. So you build them, you put them underground, they clean the water to a certain extent, but you're not getting any other benefit from them. So some other features, especially bioretention, we're going to get a lot more multifunctionality and additional benefits.
What is wet retention versus dry retention?
Okay, so wet detention would basically be a detention basin that stores water in it. So it has like a static water surface elevation. It's a little more of amenity. So we'd have to really make sure there's adequate runoff to feed that and maintain that water level at like a 6-foot depth or more, just to keep the water quality good. Yeah. So that gets into a little bit of a water balance issue, but it provides better treatment than like a dry detention basin.
We usually call the difference between wet and dry, we call dry retention and wet detention. And that's what they did in Florida. Like, one's gonna be wet, the other's gonna be a big grass field that you play on, but when it rains, it'll have 3 feet of water on it for 4.5 hours. And you can't play on it for another day because it's all super saturated. Let me just quickly, so here, water table, are there aquifers and so forth that you feed off of, that you get water from?
Yeah.
But they're not here.
No, there are aquifers here.
But I mean, so for instance, when you have a bioswale and it's recharging the ground, is it just making the ground happy and wet, or is it going somewhere and recharging an aquifer? Yeah.
It's going to depend on where it is specifically, and like depth to seasonally high groundwater, which is usually something we want to look at in terms of are the pollutants traveling. That shouldn't be an issue for this particular project. Other projects in the area that are like right on the coast, then the seasonally high groundwater might be fairly high and more of a concern.
But there's no active groundwater under the zoo, right? Is that true? There's not a groundwater basin under the zoo itself. Nobody drills down there and pumps a well.
No.
Right.
Yeah.
So in that case, something like the bioswale here, it's an interesting thing, but it's not doing what you do in Florida. Florida has this big matrix of subterranean aquifers, and every time you can put water back into them, it's a good thing. Is there a same kind of principle here? Is the benefit like to a swale recharging water into the ground here like you would in Florida?
Well, there's a benefit in that once, like, if you put water, first of all, it's like so much cheaper to store water in the soil or in the earth than to like build a structure to contain it. And so then once you put it in the ground, you know, it's there, it's more available for the plants, so it can assist with water conservation in the long run. So it's more like maintaining or restoring the pre-development hydrology, regardless of what that hydrology is. So it's very different here than in the Gulf Coast or whatever, but there's still, the pre-development hydrology is what it is, and so the idea is trying to mimic that to better support the plant and the animal life that will be there. Now we're going to end up having, except in the California section, more of a designed system that maybe wasn't specifically indigenous, but still the pollutant removal capabilities of bioretention are really pretty phenomenal. Now, if it's just draining, if it's draining off the hillside or an exhibit, there may not be, other than sediment, there may not be a super heavy pollutant load coming off of the hillside. Now, exhibits could have high bacterial loads, high nutrient loads, other pollutants like that get into them, and even the path, the parking lot, so hydrocarbons, metals, and other things, and even the paved paths within the zoo. You've got the vehicular traffic just from maintenance and such. People are tracking in sediment, they're tracking in, maybe bacteria and other things. So even that will tend to help.
But if we stuck a well out there in the parking lot and pulled water out of underneath the parking lot, I mean, would we get a significant amount of water?
Right, yeah.
And if we recharged it, would we get a source of water out?
Might be worth.
I don't know.
Might be worth dropping a test just to see what, or maybe I guess there might be some data out there that says what's around here.
Yeah.
But I mean, that was the whole concept of doing the parking lot.
Exactly.
Was to charge that ground and to clean it versus going into the river. Those were the two goals, but you need to know if there's anything down
So
there.
that, like you said, it's a lot cheaper to store down there. So if you stuck a well down there and pumped it up and fed some of the exhibits off of that groundwater, I mean, maybe a very localized groundwater. I just don't know what the storage capacity is.
Yeah, we'd have to look at the parking lot design and drainage area and that. But yeah, so there's lots of possibilities. So most of our projects, this is kid geared. This was an elementary school out in Riverside County for New View USD. But you notice the emphasis on maintenance on this overview sign. Just because I think with the zoo, there's going to be more consistency with some of these other organizations. But as facilities staff turnover, the idea is having a history of what really needs to be done. And so, of course, there's more like specific operations and maintenance plans, which I'm sure you guys are familiar with for other operational things. This was for City of Santa Monica for their BMPs maintenance manual. And so BMPs can range from, this is underground storage. This was done as a grant and demonstration project. It's below an inlet within the road right-of-way. And so it's manufactured storage cubes that retain water. So this is one type, and I'll show you a couple more examples, but this is one type of underground product that could be used like in the Africa area to store the water to make up the river flow. This is a manufactured dry well, so it has some storage in it, but it also, the idea is infiltration. So the BMPs can vary, and BMP is just like in other industries, best management practice, so they can vary from manufactured BMPs, which have very specific design, very specific goals, and what they're trying to remove, specific maintenance requirements. There's a little more creativity, and I think for a zoo, there's plenty of land in general. The non-manufactured BMPs, more of the green infrastructure, at least add a lot more in terms of the experience for people and for kids at the zoo. So this is bioretention in the city of Santa Monica. So they have a mix. And these are pretty small scale bioretention areas. They've got several of them along the road right of way. Porous concrete, it's a strip down the alley. So people aren't really supposed to wash their cars, but in this case they were, and the runoff is going down and getting treated by the permeable pavement. So it can do a pretty good job. It's about on par with like a sand filter.
How do you keep the permeable pavement permeable?
Well, you have to do maintenance.
Because
So
I mean, some of the things we've actually had a couple of clients turn around and go forget about it because the best thing we could find was like a billy goat. It's got extreme suction on it,
mhm.
but in time, the permeable pavement clogs up with all the fines and is no longer permeable unless you have something that's strong enough that can vacuum.
Yeah, you have to maintain it with like a vacuum sweeper
Mhm.
and then periodic. So depending on where you are, like cold parts of the country that have snow, you know, generally there's going to be more times. If you have a heavy sediment load, you'll have to maintain it more frequently.
Mhm.
Otherwise, once a year, twice a year, quarterly, vacuum sweeping.
You think it can remain permeable?
It
If
can
properly maintained.
Not like forever, but nothing's forever. I mean, it can remain permeable unless if it's in an area of a super heavy sediment load. Then you want to build either don't put it there or build in other like pre-treatment, pre-treatment VMPs, or have a redundant system where you know it's going to do its job. You know there's a lot of sediment coming in. You're going to maintain it, but you also have the overflow goes to a different system kind of thing.
Yeah, we have permeable concrete, permeable asphalt, and interlocking pavers in the parking lot. And we do have certain areas where there are clogs, and basically it's a high. I think the one thing about it is when we first installed it. I mean, this was the first time the city had installed this type of material. So when they did the permeable paving, they didn't really care about the grade, or how you're used to grading everything at a sheet flow at a 2% or whatever, 1% or whatever. They didn't really care about it, so there was like waves in it and everything like that. That was like, but I think that they should actually sheet flow it over, because if they spread it across, you're not going to get the sediment build up in one particular
area. Yeah.
And what happened was we have one area where there is a bit of where a lot of drainage comes into that one particular area, and that's. But if it was spread across the whole surface, we would probably have enough to not have to worry about that one spot. But of the whole parking lot, we only have really one spot. So, or maybe there might be more. But basically, there's one really troublesome spot. So.
Yeah, and if it's a large area that's a pretty isolated clogging, then you're still getting your performance overall. So, but yeah, so the permeable pavement can be completely flat. You can do fairly. Not super steep grades, but you can put some grades on it. So maintenance is really the key, and then just the design
And it's unreinforced.
that depends on the geotechnical recommendation. So that
And most
varies.
recommendations we've had is not to put reinforcing in it, and then you're left with structurally can you make it work.
yeah. We've done one in Oakland at a fire station. I think I just have the interpretive sign in here, but it was permeable pavers. I think over a thicker subgrade or base. It was actually ended up being less expensive than reinforced concrete, which was kind of odd. Yeah, so permeable pavers in the parking stalls here.
Where's that?
This is also in Santa Monica. I think it's at Virginia Park. So here's a sand filter under construction. So it's underground. I mean, it does an okay job of removal, but again, it's not going to provide other benefits like educational opportunities or aesthetics. So wet pond was one of the items. This is actually in Baton Rouge, not too far from you guys, at a swamp education center.
Before the flood or after?
This is a long. My brother used to live there, so this was a long time ago.
Yeah.
It was before the flood.
The
Which
flood
one,
would have
though?
been to the roof line.
Yeah, pretty
Yeah.
bad issue.
Here's another one with a viewing area. So dry detention basin. I think that the recommendation in the BMP study was retention, but dry detention basins, they're pretty good for flood control, but they can have some water quality, I guess, issues in terms of erosion and sedimentation, and they just don't tend to function very well for water quality.
Well, the other thing we found too is that, so recovery, a lot of places we work with, you have 6 inches of rain in one event.
Mhm.
So that field won't be any good for the next 3 days, because, one, you have to get all the water moved away, and then the field has to dry enough to where it can be used. So it's a great dual use, but like everything else, something that does 2 or 3 things, probably doesn't do it as great as if you just hit one thing, do it one pump. So
Yeah, I think that's probably true for the detention basins with recreation, but like bioretention that has so many pollutant removal processes and then provides the aesthetics and habitat. That's really my favorite
Yeah, the best,
BMP.
yeah.
Yeah. So this is in Lenexa, Kansas. So this is also a detention basin, but it's the grasses in there. The native grasses help with water quality. I think I've got a photo of a large retention basin later on. So this is out in New View, and basically it was a parking lot. So similarly to the parking lot here, it was we retrofitted it, but the emphasis was on permeable pavement, and they wanted infiltration trenches rather than bioretention. So everything overflows. So it pretty much infiltrates 100% of the annual runoff and also the 100-year, 24-hour event. But there is an overflow built in out into a play field, kind of just in case. So here it is after it was built. This was also done in conjunction with a solar project. So there's new solar arrays in the parking structures. And you'll notice the rocks are very big if you're familiar with infiltration trenches or basins, and that's so the kids don't pick them up and toss them. But I'm in there to give you an idea of scale. So the one construction issue, we didn't do construction inspection on this. The prime consultant who did the solar did, but the one issue is that the contractor, the idea with infiltration trenches and basins is that there's a depression to allow for storage. So they filled the rocks all the way up to the top. So still probably the performance is there because you've got a lot of spaces in between, but that's the one thing. So the construction inspection and construction phase services, when you get into building these projects are really important. So the things like the permeable pavement, if it has some waves in it, that needs to be caught during the construction process. This is at the Riverside County Flood Control and Water Conservation District. If you haven't been out there, they've got a great demonstration site and walking tour. So permeable pavers, porous parking stalls.
that's the demonstration truck.
That's the demonstration track, yeah. And they actually, the soil was very sandy and they lined everything to simulate a worst case scenario of what kind of performance do you get. And it's still reducing runoff and providing water quality benefits. So in this case, it's the driving lane that's porous. So you see, I've intentionally included interpretive signs in this presentation just to emphasize, and I think several of you have mentioned the idea of the education and outreach and interpretive elements. I think that's really important, both to educate the visitors to the zoo and then also to promote what the zoo is doing in terms of sustainability and green and conservation. Right, so bioretention is really my favorite because it does so many different things, but it's more of a distributed BMP, meaning you're not going to have one bioretention area to treat the whole of the Africa exhibit. It would be more like the parking lot where you have multiple bioretention areas. More of a centralized BMP would be like the large retention or infiltration basin, wet pond, those types of things. So this is also at the Riverside County Flood Control District, and it's just kind of the final place where water goes before it leaves the site, and it's their infiltration retention basin.
And you have the statistics on how much treatment you
I-
get out of those bioretention?
I do, or I can access them, but it hasn't rained very much since they built it, so there's not a lot of data.
Yeah, but I mean, from
but
a
in general,
theoretical-
yes. In general, yeah.
Right.
There's been many studies. So the certain things like nitrogen can be a little troublesome with a lot of BMPs, but there are design modifications, or sometimes if it's a concern, we can pair up a couple of BMPs.
It just increases the nitrate is what it does? Or?
Well, it depends on, you have to be careful, don't use, soils or compost with animal products in it, because that might tend to leach. So, and then these types of systems don't really provide denitrification, which is required to remove nitrate. So unless you can incorporate in design modifications where you create an anaerobic situation kind of below ground to help with it, but really depends on what are the pollutants of concern.
How about phosphorus?
Phosphorus removal is not like super good with bioretention, but again, you can pair it with different products. So anyway, this whole site is very heavily monitored, special monitoring building.
That's a probe.
Yeah,
I would think.
and this is stormwater. This is in Oakland by Lake Merritt, so it's just an example of a vegetated swell. So the difference between a vegetated swell and bioretention is swells generally have a little bit of a slope to them. They're going to carry water and provide some treatment. Bioretention, on the other hand, is going to be flat bottom. It's going to hold the water, let it sit there, let it filter through, and provide better pollutant removal. So still some water cleaning processes with the vegetated swells. You can get into things like carbon sequestration, interaction of mycorrhizal fungi with the plant roots for pollutant removal. This is a rain garden in Portland at an elementary school. I'm standing back in it. So these can be really beautiful features depending on how they're planted. And so again, the idea with the bioretention, just like permeable pavement, if sediment gets into it, sediment has to be removed. And that's the case with any BMP, whether it's manufactured or more of a design natural system. But sediment will tend to collect on the top layer of the mulch. And so like annually you remove and replace the mulch, and you're removing the sediment from the system. But you have different processes that occur. You have mechanical filtration, where the sediment settles out by the time it gets about 12 to 18 inches down the soil column. You have phytoremediation occurring. You've got biological processes, bioremediation and biodegradation.
But not denitrification.
Not unless you're specifically designing for it. And then porous pavement. So, again, you've got your pavement layer, whatever the material is, it all works about the same. And then some level of gravel. And the gravel is sized two ways. One way is based on what's required structurally. And then the second way is what goals are you trying to achieve? How much storage do you want? What are the infiltration rates? That kind of thing, to be able to balance the system. So porous pavement can work really well in terms of managing the hydrology, and we can pair it with other products so that we're providing storage underground. So some products look like milk crates. These have circular cutouts in them. Ace mentioned more like pipes and manifolds. There's a lot of different products out there. Here's this one under construction in Citrus Heights up by Sacramento. And then this is the fire station I mentioned in Oakland. So the driving lane is permeable pavers. What's weird here is that the fire station personnel are supposed to maintain everything, and everybody knows that they're not going to. So this is one of these systems where they do a really good job with their trucks, but they're not going to be experts in maintaining BMPs, and they don't have a vacuum sweeper. So this has a redundancy where there's a trench drain that drains out into bioretention that's actually sized to treat the entire site. So if the permeable pavement clogs, it's still there providing the structural support for the trucks, but we've got a backup. I'm standing in this gray water system. So this is more, I built this. And there's all different styles of gray water systems that you can use. This is kind of like, backyard, small scale, laundry to landscape, but you can do them on a much larger scale, more manufactured systems, treatment, and reuse of the water that way. And then I just, I want to point out, and I think that there's going to be different styles within the exhibits in the zoo, different types of water use. Of course, like the California friendly, the indigenous plants, low water use are going to be really important in certain areas. But there are going to be areas where the theme of the exhibit is going to be maybe require higher water use plants. And so we can, balance that out with efficient irrigation, incorporating in other conservation BMPs, and then also through the stormwater capture and reuse, better provide a source for the irrigation for the more water intensive areas. So I think in certain exhibits, if the focus is more, on a part of the world that has more water, you want it to look like that. And then again, keeping it, very kid-focused, animal-focused. I think that pollutant removal and water quality benefits and hydrology benefits are important and can be emphasized, but also since it is a zoo, with the interpretive elements, as much, making about the animals in nature is hopeful and fun. So. Little rain barrels are cute exhibits, but they really aren't going to accomplish much. So, if there's a way to work in, some larger cisterns as a demonstration, but also where they can be functional. So they need to be able to collect enough water and sited next to an area that there's a need. And it might be that toilet flushing is, more consistent need that works out with the cisterns. All right, so a few final thoughts, just again, make it fun, make it educational, and make it relevant for the kids and the visitors. And I think there are a lot of opportunities to integrate water conservation and stormwater throughout the zoo. I'm super excited to be part of it, and just keeping in mind, planning for the maintenance down the road.